Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0325-16 indicates that there is a low voltage detected in the knock sensor circuit of the Honda CR-V 2023 and newer models. The knock sensor, an essential component in the vehicle's engine management system, helps in detecting engine knock or pinging. It sends a signal to the powertrain control module, PCM, which adjusts the ignition timing to prevent engine damage. This DTC is triggered when the output voltage from the knock sensor falls below a specified threshold, prompting the PCM to identify and store the fault. The PCM acts as the central processing unit for many vehicle functions, making its proper operation crucial for engine performance. Understanding the location and function of these components will aid in effective troubleshooting and ensuring the vehicle runs smoothly. The error associated with DTC P0325-16 revolves around the knock sensor, which is integral to an engine's performance. The knock sensor is typically located on the engine block, often near the cylinders, and operates by detecting vibrations caused by engine knocking. When it identifies excessive knocking, it provides feedback to the PCM to adjust the ignition timing accordingly. The functionality of the PCM is critical, as it interprets the data from the knock sensor to maintain optimal engine conditions. In cases where the knock sensor output voltage is low, the PCM records the DTC, signaling the need for further investigation. Familiarizing oneself with the vehicle layout and knowing the exact position of these components eases the troubleshooting process. Several potential causes could lead to the triggering of DTC P0325-16. First, a faulty knock sensor can fail to provide accurate voltage readings to the PCM, resulting in this DTC being stored. Secondly, shorting in the wiring between the knock sensor and the PCM can lead to low voltage or complete loss of signal, impacting engine management. Moreover, an issue with the PCM itself, which is responsible for processing input from various sensors, could also be the root cause if no problems are evident in other components. Therefore, each of these areas must be carefully inspected as part of the troubleshooting process to identify the exact fault. The symptoms associated with DTC P0325-16 can significantly impact the vehicle's performance. Drivers may notice poor engine performance, characterized by reduced power or responsiveness, especially during acceleration. Additionally, if the knock sensor is malfunctioning, it may fail to detect engine knocking, leading to an audible knocking noise that could further damage engine components. A common symptom is the illumination of the check engine light on the dashboard, which serves as a warning to the driver that an issue exists with one or more engine management systems. Recognizing these symptoms promptly allows for timely interventions that can prevent more extensive engine repairs. In the first troubleshooting step for DTC P0325-16, begin by turning the vehicle to the on mode without starting the engine. This action powers the vehicle's electrical systems and allows the onboard diagnostics to run. The next step involves inspecting the knock sensor's output signal, while considering the specifications stated in the service manual. Since a direct test of the knock sensor is not feasible, ensure that you are examining the sensor's connections, wiring integrity, and the absence of any visible damage. If the knock sensor outputs a voltage less than the required threshold, this confirms that the knock sensor may be faulty, prompting further inspection of its wiring and connections. For this second step, disconnect the knock sensor connector and the PCM connector B. Ensure that you've performed a shorting test on the SCS line using the HDS tool before making any disconnections. This step allows for further isolation of the issue. After disconnection, Check for a shorted wire by testing between the knock sensor terminals and the ground. The expected outcome is that resistance should exceed 1 megaohm. Anything less indicates a potential short circuit. If you find any wires that are shorted or misconnected, this could clarify why the PCM is receiving lower than expected voltage from the knock sensor, leading to a targeted repair process. In the third troubleshooting step, focus on inspecting the integrity of the wiring associated with the knock sensor. This involves checking for any physical damage, such as frays or breaks in the insulation, that could expose the wire to short circuits or interference. You can conduct an open shorted wire inspection, as per the service manual's guidelines, to systematically determine the condition of the circuit. This process will highlight if the wiring is intact or if there exists a fault causing the low voltage symptom. Always ensure the connections are clean and free from corrosion, which could also impede sensor function and lead to the DTC being triggered. In the final troubleshooting step, if all prior inspections come back normal, the focus shifts to the PCM itself. The PCM may malfunction and fail to process the knock sensor input accurately, leading to the low voltage condition indicated by the DTC. Evaluating the PCM's functionality and its connections is essential. If you determine that all other components are in proper working order, it is likely that the PCM is at fault, necessitating replacement or reprogramming. Ensuring that the PCM is in good condition is vital, as it is fundamentally responsible for various engine functions and management, including timing and fuel mixture adjustments. Once repairs are completed, it's crucial to clear the DTC from the PCM. This action resets any previously stored fault codes and allows the vehicle's systems to run fresh diagnostics. Following this, conduct a test drive under various operating conditions to ensure the vehicle performs well without re-triggering the DTC P0325-16. Monitoring the vehicle after repairs provides a solid verification of the successful resolution of the issue. If the symptom resumes or the DTC returns, further investigation may be necessary to ensure all related components were addressed appropriately in the troubleshooting process. To prevent future occurrences of DTC P0325-16, implement a routine maintenance schedule that includes regular checks of the knock sensor and its associated wiring. Ensuring that the knock sensor is securely connected and that its wiring is free from damage or wear can preclude potential issues before they arise. Additionally, maintaining cleanliness around the connector and ensuring no moisture intrusion will aid significantly in prolonging the lifespan of these components. Regular inspections will not only help in early detection of faults, but ultimately contribute to the overall longevity of the engine and improve performance. In summary, the DTC P0325-16 indicates a low circuit voltage from the knock sensor, requiring systematic troubleshooting to determine the underlying cause of the issue. Understanding the role of the knock sensor and its connection to the PCM is vital for effective diagnostics. Always follow the prescribed steps in order, ensuring that all components maintain their integrity and functionality. Clear documentation of findings throughout the process will facilitate tracking progress and verify the effectiveness of repairs. Consistent preventive maintenance practices are essential to mitigate the risk of recurrence of similar DTCs, ensuring long-term performance and reliability of the Honda CR-V. Please like and subscribe to the channel. See you next time.